Okay, what we're talking about today is Lesson 1 and Lesson 2. First, we'll be discussing Lesson 1, which is classifying real numbers. A set is a collection of objects. Each object in the set is called an element, and we use braces to denote a set. Now, braces are this symbol right here, okay? Parentheses are not the same thing as the braces, okay? If you are telling me that it's a set, or you are giving a set of numbers, you have to use the brace symbol. So there are three types of sets. We have a set with no elements, which is this first one right here. And if it has no elements in it, that means it's null or empty, and we can show that by giving the braces that have nothing in them, or by drawing a circle and that slash through it. A finite set means that there is exactly this in the set. So that's number 2 here, the finite set. And in this set we show 12, 2, and 4 being in that set. Those are the only numbers in that set. We see that they are listed with commas in between, and it's closed off with the braces. Now, an infinite set, we give this example, which has 1, 2, 3, comma, and that dot, 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 which is the ellipse. This dot, dot, dot means that this set continues in the same pattern in this direction. This direction would be the positive numbers, which means that our next number in the set would be 4, 5, 6, and it continues. Okay, so the real number system is what we are going to be working with this school year in Algebra 1. And in the real number system, it branches off into two different subgroups. One subgroup is the rational numbers, and the other subgroup is the irrational numbers. Okay? We'll talk about the irrational numbers first, because it is a group that doesn't have any subgroups to it. That's just it. So they give us examples of radical 2 and pi. Numbers that are irrational are numbers that are non-terminating decimals that do not repeat. And for instance, we know that pi we round it to 3.14. And when we round it to 3.14, we know that that number continues on and on and on and on. And it goes in no specific pattern. So that's what makes it an irrational number. If we punch radical 2 into our calculator, we get 1.4142135662, and it stops in our calculator, but really it keeps going. So it has no pattern, it's non-terminating, which means it does not end, which makes it an irrational number. Rational numbers are numbers that can be shown as a fraction, okay? They terminate. So for example, 1/4, if we change 1/4, let me see here, 1/4 we know as a decimal is 0.25. What happens if we look at a number like 1/3? If we look at a number like 1/3, we punch that into our calculator, and that gets us 0.3333, and it keeps going, right? We know that we would write this as 0.3 repeating. Okay, so these are the two types of decimals that we're talking about for rational numbers. They either terminate, like 0.25, it ends, or it repeats, like 0.3 repeating, it keeps going. Integers we can think of as numbers that we would show on a number line. So if I drew a number line, the numbers that I would show on that number line, normally we always just start with putting what in the middle? 0. To the right we put our positive numbers, so we have 1, 2, 3, and it keeps going. To the left, we would have our negative numbers. So we have -1, -2, -3, and again, it keeps going. So our integers are numbers that we show on a number line, which is what we show right here. This is the set of integers. Notice that we have the ellipse on both sides because the numbers keep going in both the positive and negative directions. Whole numbers, those include our counting numbers, which we know as the set of counting numbers. We'll go ahead and move down here. That's our natural numbers. We know those as 1, 2, 3, and those continue. Those are the numbers that we use to count. Now, our whole numbers are those exact same numbers, 1, 2, 3, and they keep going, plus that 0. We have 0 for whole numbers also. So this is a Venn diagram that is generally used to help us understand how the subsets work, because the set of natural numbers is included in the set of whole numbers, and the set of whole numbers and the set of natural numbers are included in integers. And then integers, whole numbers, and natural numbers are all rational numbers. And all of those are real numbers. And then on the other side, we just have irrational numbers, okay, which we know that's the only subset on that side. Okay, so we have real numbers, which is the number system that we'll be talking about this school year. And that's split into two subgroups of irrational numbers and rational numbers. And that rational number side has more subsets to it. So, for example, it wants us to identify the subsets for the numbers given. So I would like for you to go ahead and pause the video, and I want you to write down all of the subsets for the numbers given. So go ahead and take the opportunity to pause now. Okay, so if we're looking at A, 1/2, we see that this is written as a fraction. So whenever we look at this, for us to first determine whether it is a irrational number or a rational number, we should look at it as a decimal. So we know that 1/2 as a decimal is automatically 0.5, and 0.5 is a terminating decimal, which means that it is a rational number. So we say that it's rational. And it's not going to be an integer, because that would not be one of the tick marks that we would show on a general number line. So it's just rational, and it is also real. Okay. The number 5. Okay. We don't need to change that at all. We're just talking about the number 5. And what we want to do is we want to look at the smallest set that the number 5 fits into. So we have real numbers, which is that whole number system. We have rational and irrational. And 5, we know, is also going to be a counting number. Okay, that's the smallest subset on the rational number side. Because if we count 0, 1, 2, 3, 4, 5, it is a counting number. So we start with counting numbers. So we say that it's a counting number, or natural. The next subset after counting is whole number. Then we have integer. Then we have rational. And then we have, real. I have a new tablet that I'm working with. I'm not real versed with it yet, so you're going to have to bear with me on the poor handwriting. Hopefully it'll get better. So these would be all of the subsets for the number 5. It is a counting, a whole, a integer, a rational, and a real. And finally for C, we have 3 radical 2. Radical 2 happens to be one that we talked about whenever we were giving examples at the beginning, and we said that radical 2 was approximately 1.41. But it keeps going, and it doesn't go in a pattern. Well, if it keeps going and there's no pattern, that means that it is an irrational number. And anything times an irrational number is automatically an irrational number. So I have that 3 radical 2 is going to be irrational, and irrational numbers are also real numbers. Okay. Example 2 says identify the sets of numbers. Okay, so if we're talking about the number of pencils in a classroom. Okay, the number of pencils in a classroom. I understand that you could have a half of a pencil sharpened down or a third of a pencil sharpened down, but we aren't going to talk about it like that. If I ask who has a pencil in the classroom, you're not going to raise your hand and tell me I only have a half of a pencil. You're going to say, yes, Mrs. Dotson, I have a pencil. So it doesn't matter the size of the pencil. We're just talking about the number of pencils, which means that we are counting them. So that would mean that the number of pencils in a classroom, it says to identify the sets, which means that there will be more than one. So if we're counting the number of pencils in a classroom, we would start with counting numbers. After counting numbers comes our whole numbers. Oops, whole numbers. Our integers. Our rationals. And our reals. Okay. Next, the cost of an item at the store. Okay, the cost of an item at the store. So whenever you buy something at the store, it generally has a what? I hope that you're thinking decimal, because that's true. You go to Casey's and buy a bottle of soda, it's like $1.60 something now. Okay, so since it has that decimal, the decimal does not keep going, right? It's not repeating, but it does terminate. We only pay things with 2 decimal places. That's because pennies are our smallest amount of money that we have, so we can only go to those 2 decimal places. So for it to be a decimal number, for example, if we said it was $1.62, okay, if this was the price that we were paying, we would say that this number is a rational number and also a real number. Okay? Alright, it says the surface area of a sphere where the radius is a rational number. So first of all, it's probably unlikely that you know the formula for the surface area of a sphere off the top of your head, but it's going to have to do with a circle, okay? And whenever we're finding the area of a circle, there's one thing that we always have to use, and that is pi. And I told you on the last example that if we are multiplying something by an irrational number, that automatically makes it an irrational number. So we're going to say, they're trying to confuse you here by saying that the radius is a rational number, but that doesn't matter because we're multiplying by pi. So we're going to say that this would be an irrational number. This is an L. And a real number. Okay?